Hello and welcome to section 7, Design Patterns, Make an Informed Decision on What's Best. In this video we're going to talk about Model View Controller, or MVC. Okay, to explain this I'm going to go through an example I've made. So it's a very simple app that allows you to split a bill. You can enter your amount, select the total amount of people you're splitting by, and it will print out the results below in the table view. So first of all, I've designed this class to be an example of a massive view controller. So a lot of people will bloat out their view controllers and do absolutely everything possible within that one class. And you end up with this class with hundreds of lines of code. It's nearly impossible to test. It's very hard to decipher there's a bug, and it's hard to read. So if you're to use MVC, which is a design pattern that is pretty common within Apple, and it stands for Model View Controller, which means you split out your classes or your code into classes that represent different aspects of a view. So your model, it would be kind of database level, or the networking calls, or even just code that represents the structure within your database. Your controller is going to be a class that is meant to take the model code or the model data and format it for the view. And it shouldn't really do very much in there apart from, well, that actually should probably be the most complicated part, but much less complicated than this massive view controller that you see a lot. I'm going to show you a way to split this out in a minute that is slightly more testable. And the view then aspect should just be like UI view and very, very little code around sort of the life cycle. There's a bit of argument about in the community if the view controller should be part of the view, or it is in fact the view controller that it is meant to be. But I actually prefer to just count the view controller as part of the view and create a new class, usually call it something like UI controller, that handles all the logic between the model and the view. So if you think of it like that, you've got all your view aspect of your views, all the user interaction and all that kind of thing, along with a view controller that is just handling the lifecycle code and whatever else is very specific to views. Then you have your UI controller, which is going to handle creating the right format, maybe for text on the screen, and taking the code from the model and parsing it so that the view has to think about anything. Your model then will be doing your networking calls or your database calls. So by using this sort of pattern, you can have your code much more testable, much easier to read, and it's very finely tuned to specific tasks for each class. And to make it obvious, I'm going to go through and show you what I would do to refactor this class in a way that makes it better, in my opinion. So this is an example of maybe a poorly developed view controller, and it's got a lot of delegates built into one class. You have sort of the logic that you might not expect to be here, you wouldn't want to be here. This is probably okay. You've got your delegate methods for the picker view, which was in the center. You used to select the amount of people you're splitting by. And you've got a lot of logic within this arguably view aspect of the class. And you've got your delegates here for the table view. So it's doing quite a lot already. This is a very small example. And just as an arbitrary example then, I suppose, we've got the save results on server. So you see a lot of people just doing network calls and doing absolutely everything in this class, and I just wanted to put this in to give a good representation of how the model would help separate this as well. So first thing I'm going to speak about is how you might lay this out. So in this case, I've got three files with different aspects of my refactor in it. Got your model, which is very simple. I'll show you it now. It's just a class, and it's just got the placeholder for the save results on server. But this class may have multiple things into it. It may interface with your other classes that represent networking or your database, and it should be made in such a way that it can be reused across multiple views potentially. But if you have one specific to a very complicated view, I think that's fine as well. But okay, so I've used the plus symbol and to a model to denote this is actually the model file, and it represents, or it is attached to the split view controller. And I've seen that quite a lot in projects I've used before, so I'll carry it on here. So I'm going to jump to the controller. Some of the changes I've made here, as you've known from other videos, we have separated out all the delegates, first of all, into extensions. Just makes it a little bit easier to read. One thing I should say that I didn't do here is I included the picker view within here, but if you're using this view across multiple pages, then you probably want to make your own class that handles all this together, because in this case we're just number picker between 0 and 100, which could be its own component if you're using it elsewhere. And that would take a lot of the functionality out of this class, which could be nice as well. But in this case, I've kept it in, as it's only used in one place. If I had a requirement later on to use it in another view, then that would be a really great time to start refactoring it out. But I think if we did it now, it'd be kind of premature optimization, which is not needed in this case. So go back up to the top. One thing I've done here as well is made these private. It's quite common for people to forget to make these private. And in very large projects, it can have an effect on the compile time if you have a lot of public-facing variables or methods. So you're best to try and keep it as locked down as you can. This is our instance of the UI controller. So we're in the view part of our MVC. This part is our controller, so the C part, I suppose. And we've got this other function here that I should describe. So in a lot of projects, I like to use storyboards, but if you have a very large project, it can be quite complicated with the referencing within the storyboards and having all your logic represented there. So what I like to do is design it in storyboards, but then apply it using code. So in this case, we've got this function from storyboard, basically just takes it out of the storyboards and returns you an instance of it. It's really nice to have this built into the class because it's linked to the class it represents, but you can also be clever about this and extend it into a protocol and inherit it in any class you wanted to use. And I'd encourage you to have a look at it, but it's quite a nice pattern, especially when you get into large projects. If you wanted to see how you call it, you just call it like this. So it makes your code's kind of nice. You don't have all this setup code in a random spot in the project. Okay, so if you didn't know it's the same, I added a comment because it's kind of a strange thing to be doing, I suppose. You could also make it a function and describe it well as well. So our class is doing very little now. We've got the interface for whenever they finish entering the total bill, and our controller is handling everything in there. So there's no logic in this class because we're just meant to be a view. So the way I like to think about it, if you can keep this view basically doing nothing that isn't UI interactions or UI processing, then I'd expect to cover all this aspect of the code with the UI test or the interface test. So by doing that, all the logic should be in your UI controller and should be testable by unit tests. And I think that'll give you a really high level of confidence that everything's working. If this class is very simple, you've got UI tests covering all the sort of interactions, and you've got your unit tests covering all the business logic within your UI controller and your models, and you should really have it locked down on what's happening here and have a really robust code base. So carrying on with these table views, they don't do anything anymore, they just interface with the UI controller. So the self-row@, is basically just doing a little bit of UI components here. You might want to separate this off if it was a more complicated view into their own class, their own UI view. Our picker view things here, as I said before, it could be separated out, but it's not doing an awful lot now. We're just calling UI controller functions, and here we reload the table, reload the data whenever they've selected their value, and we need to show the results then inside the table view below. Okay, so this is the main class now that's handling our business logic. I've made it an extension of our class just to keep it together. So if you if you call on this later on, you know it's kind of associated with this. Everything's private again. We've got all the sort of business logic values here with our results and our total bill. We also have an instance of the model. And I've made this injectable so that if we're testing this class, which should be really easy now compared to testing a massive view controller, we can give a protocol for model and pass in our own mocked out version, and then we can test this thoroughly below. But everything's been pulled out now into their own functions. I've separated them out with these marks just to keep it clean, but you can separate it out in extensions again, or even have separate controllers for different parts of it. I think that would be acceptable, especially if you're splitting out your picker view. You could do the same again if it was complicated. Have your own MVC pattern for that aspect of your code. So we're updating the results. We just remove the previous results. Then we take total bill and divide it by the amount of splits we need. Then we run through the list and we run through the total amount of split counts and we add them to the data source for the view controller. Then here's an arbitrary example for why we need a model. Say we're saving these results to the server, maybe for analytics or something, and possibly could be saving into the local database as well. Just keeps that separated from this code as well. And I suppose your database calls and your server are going to be much more likely to be across multiple views, whereas the view controllers and the UI controllers are more likely to be specific to a view. And everything else just again split out into functions. But these things can be tested really well, so you can test this very thoroughly, and maybe you want to update the contents of it. Like, say later on you wanted to add like a $sign or something. So say later on you wanted to add a $sign, you could do that. And your test would fail, but then you can update them and carry on. So being able to test this class is really great. If you have no experience with it, but having a huge view controller that does everything, it's very hard to work with. It's my experience, very, very, very hard to test. But class like this, you can separate everything out. It's not very hard to pull these out into their own bits and pieces, have them very well tested, and reason about what's going on. And you should carry through the same sort of format throughout your code base. I'd recommend you stick to the same conventions for the naming of things, so that when new developers come in, they can pick up from previous code and apply it to their own work. If they're adding some new views, whatever, they can see really great examples and they can just apply that, and it'll be much less processing for them, sort of mentally, to go through all this code. But I hope this gives you a quick example of how you might split out a class into the MVC pattern, or a slightly modified MVC pattern, because I've added the UI controller and assumed that view controllers are in fact part of the view.